Welcome. In this video, we will going to understand about the gravitation. Okay. So, what is the gravitation? How do people think about this force? This is a fundamental force. We know about there is the four fundamental forces. Today's that are the gravitation. One, number two is the electromagnetic force. Third is strong nuclear force. Fourth, weak nuclear force. Okay. So, in this video, we will going to think about the understand about the gravitation. So, generally from the human being evolved, they started to think about the sun, about why day and night happen, why sun every day comes from one side and going from other side. Every day sun comes from east to and rise in east to set in west. In this time period, we don't know about earth rotations. Okay, so people start to think why day and night happen. At this time, in this era, Ptolemy gives his geocentric theory. He is the renowned Ptolemy is a renowned philosophist, and he gave his theory that that's called geocentric theory. According to his theory, that Earth is a center and all planets, including the sun, are revolved around the Earth. Geo means Earth, and that's why it's called a geocentric theory. So, according to him, Earth is a center. Okay, Earth is a center. It is a Earth, and all planets are revolving around it, and sun is also revolving it. That's why the sun comes from here to here, here to here, because Earth is center. So one day sun is here, and after some time it will be going to here. It is rotated. So after some time it will be displaced from here to here. Okay, that's the Ptolemy defined how the day and night happen, and this theory easily accepted at that time. Okay, after from that time to the nearly 500, just before 500 years, it is the Gupta era in India, and that's the philosopher, that is Aryabhatta, mathematician, and he is given his theory that's called a heliocentric theory. What is heliocentric theory? According to him, no, sun is a center, and earth revolves around it. According to Aryabhatta theory, that's called a heliocentric, means sun is a center, earth and all planets revolve around the sun. That's a Aryabhatta theory. Next, Copernicus is nearly about the 1400 BC AD. Okay, now we are coming in the revolution time period. So Copernicus theory. Copernicus was the professor in his university, and he started to search and support the theory of heliocentric, that Earth is a center, sun is a center, static and a center, and Earth revolve around it. And that's why he was hanged by the church, Catherine Church, because Ptolemy theory also accepted in a action of in a process of the church, and he is opposed about the geocentric theory. According to Ptolemy, Earth is a center, Earth is a land, is a place where God take birth. That's why Church Bible also accept his theory. But Copernicus is also a Christian, he's in Europe, and that's why he was hanged out. Okay, so but Galileo, who listened about the Copernicus, he support the Copernicus theory, and he started to search, he started to prove that Copernicus was true, that sun is the center and earth is revolved around it. So who make the first telescope? It is the fundamental basic MCQ question. Most of competitive examination you find it, who make the first telescope? Who make first telescope? That is a Galileo. Why make it? He wanted to look absorb the motion of the planets and sun and earth. So he on earth, so he could not check observe the earth rotation or motion, but he can observe the motion of planets and sun. Okay, so after he was also suffered from many of the suffered because of the church. Then come at the Tycho Brahe. Tycho Brahe is the person who collect all the data of observation of the Galileo's, and he did all his life to absorb the motion of planets, and that's he started the astronomy. When you're going to learn about this subject, you will listen about the Tycho Brahe contribution in a science. So he collected all the data, absorbed it. Now Kepler came and he gave all collected data in a concluded form. Tycho could not give a conclusion before the death. He was dead in his library, but Kepler gave the conclusion of Higgs and Higgs also of our own observation data. So we are going to understand about the Kepler's law. Kepler's law. Kepler concluded all the observation in three equations, in three laws. First law, Kepler's first law. Kepler's first law, which is also known as law of orbit. Law of orbit. What is this? In this law, Kepler suggests Earth, all planets revolve around the sun, and sun is at one of its foci. Every planets including sun, including Earth revolve around sun, revolve in elliptical path, and sun is at one of its foci. One of its foci. So as we know about, in a circle there is a one center, and all distance from the center to the point of the circle are the constant. That is a circle. When you are going to look the elliptical, it has the two center, here and here, and that's called as a focus. Okay, so a foci is a plural form. Okay, so that's the focus. It is the elliptical. So according to Kepler first law, law of orbit, all planets revolve around the sun. It is the ellipse, and suppose here is the two center is the sun, and all planets, suppose something is here, planet is revolve around it in a elliptical orbit, not a circle. Geocentric talk about the sun is earth a circle path, but it's also talk about the elliptical path. So sun is at the center and planets are revolving in a elliptical path. Sun can exist here or here, either here. Okay, but at a one time it is only at a here. So when you are understand, move it. Okay, that is the Kepler's first law. Let's see Kepler's second law. It is a very important, Kepler's second law. For every competition exam, it is very important. asking in every exam in a different form of it. Kepler's second law, it is also called as law of angular momentum, law of angular momentum. What he say according to him? Here in the first law he tell us sun is at the center, is at a foci of elliptical path, and all planets are revolving on a elliptical path. So next law he tell us if we draw a line from the planet to the sun, we take a line drawn from a planet, and after some time planet will become here, and we take a distance from here, and suppose it take a t1 time to cover from here to here, and in same time period it's travel from here to here. Then this area is equal to this area. If it is A1 and it is A2, then in time T1, if T1 is equal to T2, then E1 is equal to A2. Means planets cover in same time, cover the area in same time will be cover the same area at the same time. So in different form we can say it is the aerial velocity. Is constant. It is the mathematical. I show you here. A dA over dt is equal to r dr is equal to j upon 2m, and it is a constant. So we can look here, j is equal to constant. That means Kepler's second law support the j is the angular momentum. How we define the angular momentum? J is equal to linear momentum with the time, with the distance. Okay, this is the angular momentum, linear, and it is defined as like this way, and we remove it in a circle form. So m v r sine theta. This is the angular momentum. So generally here the angular momentum is a constant, means every planet, angular momentum of every planet who revolve around the sun is a constant. Okay, now look it is very important. In exam it will cause from this format or this form, or Kepler's support the which momentum, they are asked in a different format. So only understand about this equation, j upon 2m is equal to dA over dt is equal to constant, and this way. Let's look the next law. Third law, Kepler's third law, which is also known as law of time period. Law of time period. According to it, it told us that the square of time period of any planet is proportional to the this is the law. What is A? Look at when you're going to understand, look the elliptical path. It is the ellipse. It's the foci. It is the major axis, and it is a minor axis. We are generally denoted it B and B. It is A and A. So total distance of the major axis is the 2A and minor of the 2B. So here we take another half, that is A. So that's it told us the square of the time period of a planet is proportional to the half or semi-major axis cube of semi-major axis. The time period of a planet, the time period of planet, the square of time period of the planet, the square of time period of planet is proportional to, directly proportional, not universally, sometime you will be confused, is directly proportional, is directly proportional to the cube of semi-major axis, semi-major axis, and that is t square proportional to aq. Okay, it is very important. Understand about the every time. Generally, Kepler's law questions comes in every competitive exam. You are going to IITJ, you are going to look. You can look it in a NET exam, in NDA, in CUAT, everywhere you got these questions. First law, elliptical path. Say sun is the center. Second, aerial velocity is a constant. Linear angular momentum is a constant. Third is the time, the t square proportional to b. What is mean of it? Okay, it is the law. How you can use? Okay, let's say is the application. How we will be used? How the question will comes? T proportional to aq. Okay, its mean t square is equal to k aq. K is a proportionality constant. Proportionality constant. Okay. So we can look it also here, T1 upon T2 square is equal to E1 upon E2 Q. You can write it here, write it like this way. So here, if we know about T1, we know about T2, if we know about E1, we can calculate E2. If we know any of the three parameters, we can calculate the fourth one. So that's the people questions will come in exam. They will ask a planet who revolve around the sun in T1 time period, and it's a say major axis is a distance is a suppose x meter if is the T1 and its time is a x, and how much distance will be covered after T2 time or other planet. So it will be the question mark. So in this situation, you have this and this. You can easily calculate to this equation. So these are the very important questions of the Kepler's law. Okay, now next we can look the Newton's gravitational force. Newton's gravitation. Okay, sun, earth, we understand about how the planets are revolved, which is a center. Kepler explained these things. Now Newton suggests us that every object are attract to each others, and that's attraction is called a gravitation and a gravitational force. And how will we calculate this force? The big question is how will we calculate that force? And that's why he gave a equation, a mathematical formula and equation. He was very renowned that time period. Okay. So let's see Newton's. According to him, every object, any two objects, two body attract to each other, any two body attract to each other due to mass. Its mass due to mass, and attract to each other to the mass, and this force is known as, and this force and this attraction force, and this attraction force is known as a gravitation. Known as a gravitational force. And that gravitational force is directly proportional to the product of their masses and universally proportional proportional to the square of distance between them. It is the Newton's gravitational force. Okay, so what is say? Let's look in a mathematically. Any two objects, we have mass, every object have a mass, different, other object is a m2 mass. There is a two objects which have mass m1 and m2. They are separated by a distance r. Let's suppose it's distance r. Generally we calculate the distance between the center of masses of the any objects. Okay. So according to him, the gravitational force is proportional to product of masses m1, m2. On other statement, he says is universally proportional to the square of distance between them. This is a form. We can write it collectively F proportional to m1, m2 upon r square. You can easily calculate. Don't forget this format. We will talk about how you can use in a Kepler form. I told you what's meaning of proportionality and numerical proportionality, how you are using for the numerical problems. We will do it some numericals. So here look at F proportional to m1 m2 upon r square. When we are going to replace the universally constant proportionality constant, we will get a constant that is called universal proportionality constant G m1 m2 upon r square. m1 m2 upon r square. Here G is a proportionality constant. Which is known as universal gravitational constant. Universal gravitational constant, and its value is how much? 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. So G is a proportionality constant. So I have one question for you. Is there any possibility that G will be the change? No. It was the question of the NDA in NDA exam that can we change the value of G? Which parameters, the quantity on which the gravitational constant depend? And there was for three options, and fourth is none of them. So correct answer was the none of them, because G is the proportionality constant. It is a universal gravitational constant. From everywhere on the universe, it is the constant. Second thing we look at, G is not dependent on any medium. That's why is the question. Gravitational force not depend on any medium. If you have two objects like this and this, it will be the attract to each other. We have bounded, we have more force. Okay, that's why attract. If you leave it, if you take it has the very tiny objects and have less mass, but Earth have a more mass. Okay, Earth have a 6 into 10 to the power 24 kg mass. Mass of Earth. And what is the mass of pen? Generally 200 object, it is generally 200 gram. Its mass is much larger. So which attract more force? Mostly that is a higher body. If Earth have a more mass, so it attract every body towards it. Okay. So next topic, we will understand the gravity of Earth. Okay, here we understand about F equal to G m1 m2 upon r square. This is a gravitational force constant. This is the gravitational force. That is the Newton's gravitational law. Okay, so gravitational force, memorize it. Gravitational force first, it is a attractive only. There is no repulsion. Attractive only. Second, it is follow the universally proportional to the square of the distance. We will talk in later how its meaning of. Second, third is a conservative force. Conservative force. Okay. In when we going understand about the energy, we will talk about what is the meaning of the conservative. Generally, if you are very enthusiastic, understand about the curl of F is equal to 0. If it's follow this law, this equation, it will be the conservative. If not follow, it will be not a conservative. We will talk about in a energy chapter. So these are the equation. Now let's about the Earth. Means gravity. Okay. So Earth mass is a much large. Every object which are in the surface of in an area of Earth. Suppose this is the Earth and it is the atmosphere. Atmosphere. If any object is here, it will be attract to the center of Earth. Remember that. We have take the distance from center to center. So if any object whose Earth is a mass, heavy mass, so it attract every object towards the center. Really? Okay. So we are called as the gravity. So we will going to look how the gravity acceleration. So when every object is attract, which accelerations? Is it 0? Is it something else? So it attract by the force, and which force is a gravitational force. Every object which are exist in the atmosphere of Earth or range of Earth attracts to Earth, attract it towards the center. By which force? That is gravitational force. By which acceleration? So according to Newton's second law, we have understand F proportional to m and F is equal to ma. In this case, we use the a to the g. It is the acceleration. We don't know about anything else. It is the acceleration by of Earth. Earth is a have a maximum mass. So F is equal to mg, and it attract by the gravitational force, that is g, m Earth, m any of object, and distance is equal to mg. It is a force. It is the balance condition. Balance equation or a balance condition or equilibrium condition. So here we can cut it mass and we get the acceleration due to Earth is this equal to g me upon r. Here is the three questions in your mind, that gravity due to Earth is not proportional to the mass of object. is not proportional to the mass of object. It is only depend on the mass of earth. Second, it depend on the earth is a square. It depend on the distance here. First is come to center, a surface from the center to surface earth, that is r is equal to re, the radius of earth, and then we will check the height or a depth. Okay, so this is the, it's depend only on the distance, not the mass of the object. Acceleration, it will be changed because of the distance, not because of the mass. So let's see the variation of, let's see variation, let's see variation of gravity acceleration, gravity acceleration. Let's see the first condition when object is at height. We suppose a body whose mass is m is at the h height to the surface of earth. At the center, it take it the distance from center of the object to the surface of the earth h, and the center of radius of earth is the re, and its mass is the capital M. Earth, which mass has a capital M and radius re. So according to M and G, and here F, M, capital M upon Re plus H, that's a Newton's gravitational force, Newton's second law. That is a, okay, let's cut the M, and we got G of H is equal to Z M upon Re plus H square. We can write it in a different form, G M. We can remove Re, take a bracket, 1 plus H upon Re square. We can take a common, then we look it in different form. G is equal to G M upon Re square. It is the one format, and we have other 1 plus H upon Re. We know it is the G on the surface of earth. Okay, so it can write it, G is equal to G E on the surface of earth in 1 plus H upon Re, and it will be equal to minus G. So when you take a minus G, it will use the binomial equation expansion, G is equal to 1 minus 2H upon Re. Okay, this is the gravity oscillation, variation of gravity oscillation due to the height, that is H equal to G of E into 1 minus 2H upon Re. Now let's look it in a second at a depth T. We have earth which have mass capital M and radius R. Here is the center. Suppose the object is here, it have the depth, it is the radius, and we suppose it is cover the distance d at a d height. So generally we can write simply G is equal to G M upon distance Re minus distance. We need to only take the distance. So distance from the center and its center, that is a Re minus d. Okay, so Re minus d, and it is going to square, and we can write simply Z of d G M, take the common, Re square, 1 minus d upon Re, it's going to be the square. Okay, so it is the GD is equal to G E into 1 minus d upon Re, and this is the because of the depth. So gravity oscillation due to the depth is g into 1 minus d upon re. At the center, at the surface we know g mm upon re square, and it is the value of 9.8 meter per second square. In next videos we will look how the weight will be changed when lift going to up, down, stop in different conditions. Also we try to understand about the weight loss, where the gravity will be 0 and lots other things. So thank you for watching.